Start the class. So, good morning, everyone, and this is a bright new day and a bright new lecture on ray optics. Now, what we are going to study today might come in the exam tomorrow, day before yesterday, Sunday, 28th of August was your JEE Advance. I hope you know what is JEE Advance. And in that JEE Advance, we saw a lot of questions coming from this ray optics. One matrix match type question was there. Simple question actually. There were four different questions you have to solve, and then you have to match a matrix match question on lens, and on two lenses had come. One question on simple plane mirror had come. Very simple question on geometrical optics, which we are doing right now. And the third question was also there, where there was a mirror and there is an object moving towards the mirror, and then you had to find something. Now that something wala question we are going to do today. The only difference being the question that came in JEE Advance was based on a curved mirror. And right now we have not started with curved mirror, so we will be doing the same question, similar question. Remember, uh, the question that we do, exact question may not come. I took a I took a small crash course for this class for 10-12 classes. We covered very small topics, but whatever I told them that there will be a question from latent heat and change in volume. That question actually came in the examination hall. Whatever I did in thermodynamics, whatever questions I did in thermodynamics, same question had come in the examination hall. I told them about electric current. I told them a specific formula of electric current where you have variable resistance. Same formula had come with 4 mark question. Same question, literally same question. I told them don't solve this question. Just remember the formula that you get. It was a question from SCV. I told them just remember the formula. I don't know. I'm having this feeling that this question might come, and that question came exactly. So I only covered 2 or 3 topics. I covered magnetic field and a very simple question on magnetic field had come. I had done more difficult question than that. So please be attentive in the class, and whatever we do, if you can only do that much, that is more than enough. So having said that, let us move on to today's class, and we were noting some important points about what? About images formed by a plane mirror. We were doing these characteristics of image formed by a plane mirror. We had seen U is equal to V, object is real, image is virtual, line joining O2I is always perpendicular to the mirror. I hope that you have gone through what we had done in the previous class. I always keep on telling you, whenever you come to the next class, please revise whatever you had done in the previous class. We had seen what do you mean by field of view. Whatever area you can, whatever region you can see the image is known as your field of view. We had done a question on that as well, a simple question. Maybe the same question might appear in the next JEE Advance. Then we had seen for extended object, the size of the object and the size of the image is same, or magnification is 1. It is 1. Then what we had seen was object is erect, image is erect. Object is inverted, image is inverted. We had seen that. Now we had also seen that the images left and right, they will change. We had also seen what is the deviation caused by a plane mirror, and we had seen that if you want to see the full image of yourself, what should be the minimum length of the mirror. We will proceed on similar lines, and now we will again, as I tell you, bacha, whatever I am going to tell you, just note them down and just remember them, because in the examination hall you will not be asked to solve this, you will be asked a question based on this. So remember them. Point number 11 is where we start from. Point number 11, up till point number 10 we had seen. Why I'm writing 10 when I'm saying 11? Something wrong with my head. Point number 11. Now in point number 11, what is going to happen is things are going to rotate. So there are two things that can rotate. There are two things that are there. First thing is your mirror. So let us say this is my mirror. Remember, we are talking about a plane mirror. This is my mirror, and this is the perpendicular to the mirror. What happens? And then we have an incident ray. We have an incident ray. Now, if we have an incident ray, we will have a reflected ray. If the angle of incidence is theta1, the angle of reflection would be theta1. We have already done that because incident ray, the angle of incidence and the angle of reflection are same. Now what happens if I keep this fixed, if I keep the mirror fixed, but I rotate or I turn the incident ray by some angle, let us say phi. I can turn it this way, I can turn it the other way. So I'm just making the turned ray as hash 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 hash. I've turned it by an angle, let us say phi. What happens to the reflected ray? Remember, this mirror is fixed. What happens to the reflected ray? It's a simple question that does not have a complicated answer. If you can understand this, probably you will be able to do a so-called difficult question in a JEE. What happens if I turn this incident ray by an angle of phi? Anyone? What happens to the reflected ray? Hash 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 is the new ray. If I call this ray as I, the new ray is I dash. If I call this reflected ray is R, the new reflected ray will be R dash. Where will R dash come? What will happen to R dash? Tell me fatafat. No idea? It's a simple question. Remember, only simple question come in JEE or a NEET or a main or an advanced or a bit set or whatever. It will rotate too, sir. Yes, Abhinav, that you are correct. It will rotate too, sir, but by how much angle? That is the only question I am asking. It rotates. Where does it rotate? Right hand, left hand, and how much does it rotate? That is the question. Anyone with an answer? No one knows the answer. Well, the answer is pretty simple. Right side with the same change. That is correct. The new angle of incidence, as you can see, my dear friends, the new angle of incidence, is this blue, this big blue. And the angle of incidence and the angle of reflection are same. So if this is the new reflected ray, this has to be the new reflected ray R dash, and this will be the new angle of reflection. And remember, this new angle of incidence and this new angle of reflection, they are same. Do we understand this? Can I have some raise hands from everyone? This is going to happen. Yes or no? Great. Now I am going to do this other thing. And what is the other thing that I can do? What is the other thing that I can do? What is the other thing that I can do? Instead of turning the incident ray, what I can turn? Instead of turning the incident ray, let us first draw the incident ray. So this is my incident ray I, and this would be my reflected ray R. Not a problem. Now instead of this is the original mirror M, and this is the original normal N. Now what will happen if I, instead of rotating the mirror, instead of rotating the ray, I rotate the mirror? So let us say I rotate the mirror. I rotate the mirror. This is the new mirror that I have created. I have rotated the mirror. This is the new mirror M dash, and I have rotated this gentleman by, let us say, an angle theta. I have rotated this mirror, let us say, by an angle theta. So what happens now? This is my new normal and dash. This is my new normal and dash.
Reflected ray will rotate with 2 theta in the same direction.
Yes. Yeah. In this case, this is the original incident ray. This is kept fixed. This is kept fixed. Now, in this case, what is going to happen? This new reflected ray will be rotated by an angle of 2 theta. Just remember this. Rotated by an angle of 2 theta. Why will it rotate? Because now the angle of incidence, if I rotate the mirror this way or the other way, depending on which mirror, which side I have rotated the mirror, the normal has also rotated. If I rotate it away, the angle of incidence has become more, angle of reflection will become twice as more because I is equal to r. So if you turn it by angle theta, it will also, the reflected ray will also turn by an angle theta. So the net angle will become 2 theta. So in that case, if you keep the incident ray fixed, but you rotate the mirror by an angle theta, what is going to happen, my dear friends, is that we are going to get we are going to get a reflected ray which is rotated by an angle theta. Do we understand this, my dear friends? Do we understand this? Yes or no? No, yes. And this is a better diagram than I had drawn, telling you the same thing. In this case number 1, this mirror is fixed and I have rotated the incident ray. This is the original ray, and then I have rotated it by an angle theta, keeping the mirror fixed. In that case, the reflected ray also rotates by the same angle. In case number 2, I have kept the incident ray fixed. I have kept the incident ray fixed. I have rotated this mirror by this angle theta, and as you can see, this normal, I hope you can see this normal also rotates by an angle theta. Therefore, theta plus theta, this new reflected ray reflects or rotates by an angle of 2 theta. Can I have raised hands from everyone that we have understood this? A simple concept, but this concept can come as a very difficult question, seemingly difficult question in a JEE Advanced, in NEET or Mains. It will just come as a knowledge question. What will happen? They will not ask you how much it rotates. They will tell you that the angle of incidence is, let's say, 60 degrees. Now I rotate the mirror by 30 degrees. What is the new angle of reflection? That is how they are going to ask the question. Will you be able to do this? Yes or no? Can I have some reasons? If you understood this concept, if you know the original angle of incidence, you can find out the new angle of reflection. That is how, my dear friends, questions are made in a JEE. I'll give you a minute to note this down. You can draw any diagram that you feel like, the original diagram that I drew. This is a just better version or a betterly drawn diagram. That is what I can say. Both the diagram mean the same thing. Nothing has changed. Do we understand this?
Sir,
Yes, bacha.
sir, that 2 theta is with respect to second normal or
No, beta,
second.
this 2 theta is not with respect to the normal. As you can see, my dear friend, it is always with respect to the original ray. This is the original reflected ray, yellow one. Do you see this, beta?
Yes, sir.
and this is the new reflected ray R2, and as you can see, this angle is between the original ray and the new ray. Original ray and the new ray. How much the new reflected ray has rotated with respect to the original reflected ray? That is, in this case as well as in this case, the angle is always between the original ray R1 and the new reflected ray R2. Are you getting my point here? Yes or
Yes,
no?
sir.
Well done. I'll give you a minute to note this down. The diagram is not at all important. The diagram is only to make you understand that if you rotate it away, the reflected ray goes away. If you rotate it towards, the reflected ray go towards. Do we understand this? Here I have reflected the mirror away from the incident ray. So the reflected ray, the new reflected ray goes away from the original ray. If I would have reflected uh, the mirror was like this, I rotated like this. If I would have rotated like this, it would have come towards the original ray. Do we understand this? Yes or no?
Yes, sir.
Okay, I'll give you a minute to note this down, then we'll move on to the next point. I want to finish plane mirrors today. I hope I can do this because there are 2 or 3 points left. Still left. And again, any of these points is going to come in your JEE or NEET. And I hope that you can remember them, mark them as important points in your notebooks. Your notebooks are the only and the most reliable source of information that you will have, that you can keep and use in the coming time. Can I move forward? Everyone has noted this down?
Yes, sir.
Then we move on to multiple deflections. What happens if I have two mirrors? Remember, I am talking about plane mirrors. What I have two plane mirrors which have an angle theta between them, and I have an object O, placed between them. How many images will be formed is the question. How many images will be formed?
360 by theta.
Yes, so in that case, what we got to do, we got to remember that important point.
If n is even, n minus 1.
Yes, we have to first find if 360 degrees, which is the total angle in a plane, 360 by theta, is it odd or even? Let me call this as m. If 360 by theta, and remember this theta is in degrees, remember it is not in radians, this theta is in degrees. If 360 by theta, which is m, is even, 2, 4, 6, 8, 10, 12, 14. Then the number of images, if I say n, which is the number of images, will be m minus 1. Remember, what does this n stand for? This n stands for the number of images. This n stands for the number of images. So it depends on whether it is odd or even. If it is even, if this thing is even, then the answer is pretty simple. The number of images will be, the number of images would be m minus 1. So if m is 4, the number of images would be 3. As simple as that. If m is 6, number of images is going to 5. Don't worry, I'll just show you a table, and then you will probably be able to understand. The only problem happens when what? When this becomes odd. Can anyone tell me what happens when it becomes odd?
If it is angle bisector n minus 1, if it is not passing from angle bisector n.
Yes, you will have to remember this. If 360 degrees by theta, which is m, is odd. Odd. The green one is odd. Then there are two cases possible. Case number A, the object is placed symmetrically. The object is placed symmetrically. When I say symmetrically, what do I mean is it is placed on the angle bisector. It is placed on the angle bisector. Then the number of images n will be same as m minus 1. So you'll have to remember, if it is placed symmetrically, the blue one, which is the angle bisector, then this n will be equal to similar to m minus 1. I hope you understand the meaning of angle bisector. Yes or no, bacha? That means, if I just show you on the diagram that I have made, if this is the angle bisector and the object is placed here on the angle bisector symmetrically, then the number of images will remain m minus 1. Do we understand this? You will have to remember this. There is no point of seeing, sir, please draw the diagram. It is just waste of time. We don't have to draw the diagram. You just have to remember this. So if it is placed on the angle bisector, which is symmetrically, the number of images will be m minus 1. In only one case you will get m number of images, and when? What is the next case that is possible? So if you know this case, you know the other case.
Unsymmetry.
Yes. If O is placed asymmetrically, if O is placed, my dear friends, asymmetrically, when I say asymmetrically, what I mean, not on the bisector. When I say asymmetrically, I mean not on the bisector. Then what happens, my dear friend? Then my n will be equal to m. I will call this. Yes, beta.
Your slide is tracked.
Oh, sorry. So when it is placed asymmetrically, then when it is not placed on the bisector, then the number of images would be same as n. Don't worry, I'll show you a table. You will be able to make out what I mean to say there, so that you don't have to solve it. One more case is left. Have you noted this down, beta?
Yes, sir.
One more case is left where you can note down. Everyone has noted it down?
Yes, sir.
Other class where I can see and hear? Okay. Then one more case is left which you can just note down. Case number 3. Remember, you will have to remember this. Ray optics and physics. You have to remember simple points. I also said in the last video that I made that, JEE Advanced, the most difficult exam is, and even this paper, it was more a test of your speed rather than your knowledge. The questions were pretty simple, but they were lengthy. If you can do them quickly, that is what is required. What will happen if 360 by n or 360 by theta is a fraction? Is a fraction.
The
Then we
integral
have
part
one.
is number of image.
Yes, beta.
The integral part of fraction is number of image.
An object is placed symmetrically, because in this case you can find out easily, and the object is placed symmetrically please note that down. The number of images is equal to nearest, remember this, even integer, nearest even integer, and I will mark it as pink, 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 pink. Different colors I use so that you can get the essence of this. These all things you'll have to note down and keep in your memory forever and ever and ever. If it is a fraction beta and the object is placed symmetrically, it will be equal to the nearest number of nearest even integer, and I'll just show you a table and probably you will be able to understand this when you give me a go ahead ki sir we are done with this. So I'll just show you a table with different values of theta, and you will be able to make out what we have just discussed. Are we done with this, my dear friends? Are we done, beta? Have we noted it down? Okay, I'll give you time, don't worry. I've got lots of time right now. We are going pretty slowly. I understand that, but we are trying to make things easier for you and not make it tougher for you. Have you noted it down, beta?
Yes, sir.
Yes, sir, completed.
Completed? The students in the other class completed?
Yes, sir.
Great, sir. Then, sir, this small table, sir, will make us understand the entire concept, sir. You don't have to write it down. This is just for you to understand the concept. If the angle is 0, that means both the mirrors are parallel. Everyone knows the answer, right? This is not defined, so you will have an infinite number of images. Yes or no? We understand this. If theta is 30 degrees, so you divide 360 by 30, it's an even number. It's an even number. It's an even number. No matter how you place it asymmetrically or you place it symmetrically, it will be equal to n minus 1. So you will have 11 images. If the angle is the green one, 45 degrees, 360 by 45 is 8. Again an even number, so you will have 6. You will have 8 minus 1, 7, 7, 7. I hope so far so good. 60 degrees, 360 by 60 is 6. Even, so number of images 5 and 5, point made well clear. Nothing has come over till then. Now the first one odd, 72 degrees if I put 5, 72, 360 by 72 is 5 odd. So if I place it symmetrically, then I will have 4 m minus 1. If I place it asymmetrically, I will have 5, which is equal to n. Then let us talk about one more, which is 75. If I take it 75, you will have fraction 4.8. Asymmetrically, we don't have any concept. Symmetrically, you will have to look for the nearest even integer. Nearest even integer. Nearest even integer. And the nearest even integer is 4 and hence the answer is 4. Can I understand? Can I have raised hands that the point is getting clear right now with all these examples that I am doing? Great. Yeah, 90 is simple. 90 you have number of images as n as 4, so this is even. So n m minus 1 will be n, so 3 and 3. If I take one more, 112.5, just a number like this because I want to give again a fraction 3.2. 3.2 is a fraction, so asymmetrically I cannot say. Symmetrically, I'll have to look not at the nearest integer. The nearest integer is 3. Someone said nearest integer, sir. No, sir, not the nearest integer. Nearest even integer, and hence the answer is 4. Do we understand this, everyone? Yes or no? Can I have some reason? The camera of the second class has gone. I don't know why. I hope it is working fine. Do we understand this? Everyone in the class? The concept? Abhiram understands it in the online class. What about the others?
Yes, sir.
Everyone? The camera is rotating on its own. Why the camera starts dancing all of a sudden? Okay, the camera was rotated for everyone to see. Don't worry. We can have a bit of fun in the class, not a problem. Okay, I hope the point is clear to everyone. Going on to the last thing, we put the angle as 120 degrees. It is odd. If it is odd, then it is placed symmetrically. There you will have m minus 1. If it is placed asymmetrically, you will have same. Is this point clear to each and everyone in the class? Whatever we have discussed, is it clear to each and everyone in the class?
Yes, sir.
Great, sir. You don't have to note this down. If you want to note this down, you can note this down. But this is just to make my point clear what we have discussed. We have discussed 3 points. I give you all these points with examples so that these points become strong in your head and you don't forget them. I'll give you a minute if you're noting it down. Small table. Note this down. Don't have to note down each and every angle. Just note 1 or 2 for odd, 1 and 2 for even, and 1 and 2 for fraction, and you are done. Just note them down, and we shall proceed for the next topic. And remember, this next question, the next thing that we are going to do, came in the exam 2 days ago in JEE Advanced. The only problem is, the only difference is, we are doing it for a plane mirror. In the question that came eventually in the exam, it was on curved mirrors. We'll do the same thing in curved mirrors. We'll do the same thing in lenses as well. So in your case, it might come for a plane mirror, or it might come for a lens. Shall we move ahead?
Completed, sir.
Then I shall move ahead in life. Life has to move ahead, and I have also moved ahead and write this next heading, which you can mark it as important. Relation between what? Relation between velocity of object O and velocity of I means image. Whenever I write O means object, I means image, M means mirror, N means normal, L means lens. Simple, na? Relation between velocity of object and velocity of image. Remember here, the important point is origin is mirror. Origin is mirror. So whatever we are doing it with respect to the mirror. Remember when we said that U is equal to V? Remember we said U is equal to V? Do we remember this? We don't remember this? U is equal to V?
Sir.
Yes. In that case, U was the distance of the object from the mirror from the mirror, and V was distance of the image from the mirror. So your origin was the mirror. Yes or no? Do we get this?
Yes, sir.
Therefore, whatever relation we get between the speed or the velocity of object and the velocity of the image, it will be, it will be with respect to what?
Mirror.
Yes, it will be with respect to mirror. So you talk about velocity of object, or you, my dear friends, talk about velocity of image. It will always be with respect to mirror, whether it's a plane mirror, whether it's a curved mirror, whether it's a lens. The relation between velocity of object and velocity of image will always be with respect to the mirror or the lens. Do we understand this? Yes or no? We get this? I see four girls sitting in the last bench. Why is that so? There's no space. No space in the front rows, or they are having a jolly good party time over there. Why I see a desk which can only seat two people, three people are sitting there. As I told you, I'm omnipotent, omnipresent, and omnilucent, whatever. I can see what you cannot even imagine. Okay, I hope that we are studying and not discussing what is happening in the virtual world. Let us move ahead. Relation between object velocity and image velocity. Remember, it is always with respect to the mirror. So first of all, it's my duty to draw what? To draw a mirror, and this is how I always draw it. I will draw a object. I will draw a mirror, and this is your perpendicular. The object is placed here. Let us say O. Now remember, if you remember the axis is, if you remember the axis is, this is my x-axis. Yes or no? Do you remember this? This is my y-axis, and my z-axis is coming out of the board, which I can't draw here. X-axis, y-axis, and origin is on the mirror. Do we understand this? Now, this mirror is placed along y-axis, and the perpendicular is x-axis, and one perpendicular is z-axis. Now, if the object is here, the image will be formed somewhere here. Yes or no? We understand this. And we have seen that whatever distance the object is forward, the same distance image will be backwards from the mirror. Do we understand this? Do we remember this? Yes or no? Then I can write u and v in a different way, and please understand this difference what I have written. So what I have written here is x coordinate x of object with respect to mirror. Do we understand this? OM. OM standing for object with respect to mirror. Then I can write this as x coordinate of image with respect to mirror, VIM. Do we understand this? XOM and XIM. XOM and XIM. Do we understand this? Now, if the origin is on the mirror, one is on the left hand side, the other one is on the right hand side. So if one is positive, the other is negative. Do you understand this? If the object is here, the image has to be there. Origin is here. So if one is positive, the other one is negative. If this is positive, this is negative. If this is positive, this is negative. If you understand this, then I can simply write the relation XIM will be negative of XOM. If anyone has a problem, please raise it now. XIM is XOM, negative of XOM. Do we understand this, my dear friends? Can I have raised hands from everyone that we understand this? Yes or no? No or yes? Yes, we understand this. This is equation number 1, let us say. Now I can talk about the y coordinate. Now I will ask you this question. What will be y of image with respect to mirror? What will be the relation between y coordinate of the image with respect to the mirror and y coordinate of object with respect to the mirror? You can see the y coordinate here. This is the y coordinate. What happens to the y coordinate?
No change, constant.
You don't say it's constant. You say it is same as the y coordinate of object with respect to the mirror. So I will just write it here. Y O M. Is this point clear to everyone in the class?
Yes, sir.
Well done, sir. Then you can tell me the third point as well.
ZIM is equal to ZIM.
Now we are talking. ZIM will be equal to ZOM. Remember, when a question comes in JEE, it might be in the form of all the 3 coordinates. If you remember this, you can do this. Now, I'll move on to the 4th equation. And how do I get this 4th equation? It's very simple. I will differentiate equation number 1. I will differentiate, my dear friends, equation number 1. Can you tell me what is the result I'm going to get?
VIM is equal to minus VOM.
Yes, VIM. But remember, I'm talking about the x coordinate, so I will write it as x will be equal to minus of VIM. Oops, VOM ka x coordinate. Is everyone there with me together in this? Yes or no? No or yes?
Sir.
Well done, sir. Then you can write equation number 5 and equation number 6 on your own. Can I expect that? What will be equation number 5 and equation number 6? VIM will be see, I made a mistake. VIM along y-axis will be equal to VOM along y-axis. VIM along z-axis will be equal to VOM along z-axis. Is it difficult for you to understand, beta? Can I have some raise hands from everyone that we understand this? Well done. Well done. I shall give you a minute. A minute to win it. A minute to win it. A minute. A minute. Shall I move ahead in life?
Done, sir.
Well done, sir. I'm still okay. Now, remember, let me paint it green. Now remember what I mean by this. This is velocity of image with respect to mirror and velocity of object with respect to the mirror. Now, can anyone tell me? No one is going to give me the velocity of object with respect to mirror. No one is going to give me the velocity of image with respect to the mirror. I'll have to find out. Now, whenever a question is framed, and what I saw the language in the JEE Advanced, and I would like to use that language in the laboratory frame. This is the equation that I use for a question that came in JEE Advanced. In the laboratory frame, there was a question based on modern physics where there was this nucleus of nitrogen and a helium particle bombarded it, blam, and then we had a reaction. That is modern physics. We'll do this in our class whenever we do this. In the laboratory frame, in the ground frame, whatever velocities will be given to you will be in the ground frame. So it's better, if we have understood this small thing, it's better that we convert it into the ground frame. Can you tell me how will I write velocity of image with respect to mirror in the ground frame? It is very simple. Anyone? Go back to the past. Class 11th. Velocity of A with respect to B. Remember, we had done this? And that is what I call smart hard work. If you remember this, it's great. If you don't, then I will have to save your souls. SOS, I call it. Anyone remembers how will I find velocity of image with respect to mirror? I with respect to M? So sad. Velocity of A with respect to B, my dear friends, was simply velocity of A.
minus velocity of A.
No, velocity of A with respect to ground. That is what you say, beta. You don't say it theoretically wrong. Minus velocity of B with respect to ground. Everyone remembers it now. Can I have some raise hand that we understand this and remember this, beta? Now I will just put it here. Now remember, I'm not talking about velocity. I'm talking about components of velocity. So I will not write the vector sign. I will only talk about the component of velocity. So I will write this equation like this. Velocity
image
of
with respect to mirror
along x will be equal to velocity of image with respect to ground along x minus velocity of mirror with respect to ground along x. Do we understand this? Yes or no? No or yes? Similarly, I can write velocity of object with respect to mirror along x will be equal to velocity of object with respect to ground along x minus velocity of mirror with respect to ground along x. So far, so good. Are we moving in the right direction, my dear friends? Now I will put this together. Remember, this yellow one is equal to the negative of this red one. Yes or no? So now you can write them and see what is the result that you get. You will get the result in terms of the velocity of image and object with respect to ground and velocity of mirror with respect to ground. I'll give this small task for you in a minute for you to do this. I can do this on the board, but I want you to do this so that you gain confidence that you can do a question in the exam. So what is the final result that we are going to get from all of this? This yellow one is the negative of this pink one. From there you will get the result. Can I have that result? Only a minute you have to show me your talents, else I will show mine. No one? Ready? So I will write it. Velocity of image with respect to ground plus velocity of object with respect to ground will be equal to 2 times velocity of mirror with respect to ground. I have omitted the x sign because this x-axis is looking bad. So I'll just write this along x-axis. X-axis is the axis along which they are moving. Do you understand this? Do you understand how will you get this? Yes or no? Can I have some raise hand from everyone that we understand this?
Yes, sir.
And the rest, everything is same. Only question will come here. The other question will also come here. That we will do in the next class. But this is my humble duty. My humble duty to solve at least one question. And that is what we are going to do. Is everyone ready to solve a question? Yes or no? No or yes? Are we ready for the magic?
Yes, sir.
Then let's go for it. This is the question that comes. This is how questions are framed in a JEE or a NEET. Question number 1 on this. An object moves with a velocity of 5 meter per second towards right, while the mirror moves with a velocity 1 meter per second towards left as shown. So the diagram is there. I will draw the diagram. Let me not waste any time in drawing the diagram. The mirror is here, my dear friends. Mirror is moving like this. The object is here, my dear friends. An object is moving like this. Let us not waste any time in drawing the diagram. The velocity of mirror is 1 meter per second towards left, and the velocity of object is 5 meter per second towards right. And the question is pretty simple. What is the velocity of image? And I wait patiently for your answers. Then I hope you can give me the correct one. I hope everyone is making notes, including the last bench. Remember,
Minus 3 meter per seconds.
minus 3 meter per second. First of all, I don't know what does your minus mean. So you have to tell me what does the minus mean, and 3 is not the answer. And you have not told me what does minus mean.
Along negative x.
Along negative x. Okay, I understand along negative x, but 3 is not the answer. Negative x is correct.
Okay, sir.
3 is not the answer, my dear friends. I'll give you 1 more minute. I've run overtime. 1 minute overtime. That is not good. That means I am not efficient enough.
Sir,
Yes.
-7.
-7. Again, you have to tell me. You have to tell me what does minus mean.
Left side of the mirror.
Okay, that is correct. So what do I do is I take, let me use a different color, that would be better. I take this side as positive, this direction as positive. So this direction becomes negative. Yes or no? No, yes. So this becomes +5 and this gentleman becomes -1. Raise hand will give me more confidence that we understand this. Yes or no? Now I apply the simple concept velocity of image with respect to ground plus velocity of object with respect to ground must be 2 times velocity of mirror with respect to ground. Velocity of image with respect to ground I do not know. Let me call this as V plus velocity of object with respect to ground. What is the answer for this one? Yellow one. This yellow one is +5. Yes or no? Hare, say yes or no.
Yes, sir.
Thank you, sir. So this is +5. That will be equal to 2 times this velocity of mirror with respect to ground. How much is this? Hare, say.
-1, sir.
-1, sir.
-1, sir. That is correct, sir. So keep on saying this. This gives me confidence that we are on the same planet, in the same universe. -1. And from here, I will leave the question. There is no point of me solving from here on. You will get the value of V as -7 the unit would be meter per second, and that is how questions are framed, and this is how you get the answers in an examination hall. So that brings me, I hope all of you could have solved this. Can I have raised hands from everyone who could have solved this, who did solve this question? Only two. Abhinam could do it. Okay, from the last bench. And the last bench is normally the most brightest one. I at one point in time I used to sit in the last bench, but the reasons were different. I used to sleep there. And I won't suggest you to follow me on same lines. See, I've done a lot of mistakes in my life. I never want my kids to do. My kids means you to do the same mistake. So I'll tell you my mistake that I have done, and I hope you don't repeat them. On that note, I hope everyone has noted this down, and that brings us to an end of this class. In this class, we have tried to wind up plane mirror. We have done one question here. Probably I'll do one more where the object is not moving in a towards the mirror. It would be moving at an angle, because that might be the question that comes in the next year exam. So we will do that question and probably wind up with plane mirrors and move on to the spherical mirrors. Remember, you will have to remember a lot of definitions. Please remember them. I'll see you in the next class. If you have any doubts, please come up. I'm overshoot time. That's not good. Please come on time in the class, otherwise I will overshoot time, which is not good. That tells me that I am not efficient enough. Take care and see you in the next class. Bye bye. Take care. God bless you.